Let's learn about trapezoids and kites. We are going to start with a flow chart of the quadrilaterals, then we'll go through the trapezoid properties, talk about their angles and a mid-segment, and do the area formula. With kites, we'll look at their properties, angles, perimeter, and area. So let's get ready. You're going to need your notes, pencil, and calculator. Make sure you draw labeled pictures along the way, write down any vocabulary words and formulas, and try some of the problems. Here's our flow chart, and this side here is what we already worked on: parallelograms, rectangles, rhombus, and square. Notice the top is a quadrilateral. Quadrilateral means 4. So everything on this page is 4 sides. The thing about what we've already learned, parallelograms, is they had 2 pairs of parallel sides. The ones we're going to learn today, trapezoid, isosceles, trapezoid, and kite, do not have 2 pairs of parallel sides. So they're not parallelograms, but they are 4-sided figures, so we call them quadrilaterals. A trapezoid is defined as a quadrilateral with exactly 1 pair of parallel sides, and those parallel sides are called the bases. So I can put my parallel mark here, and then I know that those are the bases. So wherever the parallel pieces are, you want to orientate yourself so you know where the base is. These are all trapezoids, so remember they can turn. If I look at them, try to find what looks like it would be parallel, then I can find my bases. So there we have that, and yes, it has a right angle, a couple right angles, and that's okay. This one, you might say it's upside down, but they're still bases. And then this one is kind of slanted, and they are still bases. So those are all trapezoids. We do have an isosceles trapezoid like we have an isosceles triangle. So an isosceles triangle has congruent legs. We said that the parallel part are called the base, the bases. Well, in an isosceles trapezoid, it means it has congruent legs. So it's not a triangle, but it still has legs, and those pieces are congruent. So over here, they have congruent legs. They also have congruent base angles, and there's 2 pairs of base angles. So this is a base, and it has congruent base angles. This is a different base, and it has different congruent angles, so I use different markings. Also, about the diagonals, once I draw them, and this only works for isosceles, those diagonals are going to be congruent. They're going to be the same. So let's try an example. If I'm given that the measure of angle A is 40, I can find my parallel bases there. I am told that it's isosceles, so I know my legs are congruent. Therefore, I know the base angles are congruent. So this one must be 40. The other thing that happens in between these parallel lines, if you remember parallel lines cut by a transversal, these 2 angles are called same side interior, and they're going to be supplementary. The same thing happens here. So these 2 angles, angle A and angle B, are going to add to 180. That means that angle B must be 140. Well, that is a base angle to C, so that must also be 140. And let's see what we have here. We have 140 plus 140 plus 40 plus 40 equals 360. And we're going to find that all quadrilaterals, all 4 angles in a 4-sided figure will always add to 360. Just like when we did a triangle and they all added to 180, 4-sided figures are going to add to 360. So we need to remember that. And that's where I wrote there. So all angles of a quadrilateral will add to 360. Let's talk about the mid-segment / median. I use both words because you're going to see both words in other places. And it's basically, it's the average of, when I have the mid-segment, it's the piece that goes right through the middle, and it's exactly in the middle. So when it breaks it up, that is a midpoint there. And that's a different midpoint if this is not isosceles, or the same if it is isosceles. So this piece, this mid-segment, is the average of the bases. So remember how we find average. You take the 2 bases and you add them up and divide by 2. You divide by however many you have. So the mid-segment is 1/2 times base 1 plus base 2. Or you could think of it as adding your bases, dividing by 2. Those are the same thing. The bases. So in this example, my base is 8, my other base is 12. So I'm going to try to find the mid-segment, and I'm going to do 8 plus 12 divided by 2. So that becomes 20 divided by 2, which is 10, which means my mid-segment here equals 10. Another thing you can notice is that 8 to 10 is 2 units apart and 10 to 12 is 2 units apart. So you can use that because remember this distance here and here has to be evenly spaced. Trapezoid area formula. So it kind of looks similar to what we just did. We have the 1/2, we adding our bases, but we also have to take into account the height. And remember that the height is always perpendicular. So I dotted it in here, I called it h. So we have 1/2 times the height times the bases add together. When we're in class, we're going to do a Desmos that's going to investigate where this formula comes from. So let's try it. I have, and it doesn't matter which one you call base 1 or base 2. I'm going to call the top base 1, the bottom base 2, and then that is my height. So we have the area equals 1/2 times my height times my bases added together. Remember our PEMDAS, so I'm going to do my parentheses first. So I have 1/2 times 10 times 34. So this is not distributive. This is all just multiplying now. So I can do 1/2 times 10 and get 5 times 34. So it's not 1/2 of 10 and 1/2 of 34. And when you multiply those together, you get an area of 170 units squared. Let's switch over to kites. So kites, again, are a quadrilateral, 4-sided figure, but not a parallelogram. They have 2 pairs of adjacent congruent sides. Adjacent means right next to. So if I look at this, AB is a little bit shorter and BC is a little bit shorter. So those are my 2 short sides, and then AD and DC are my 2 long sides. And they are, AB is adjacent to BC and AD is adjacent to DC. So that's what a kite is going to look like. Once we draw our diagonals, the kite can have a few properties. So I'm going to draw those. So I draw diagonal AC and diagonal BD. And what happens if you do it correctly is those diagonals should be perpendicular. So these are all 90-degree angles all the way around. Another thing that's true about kites is one pair of opposite angles is congruent. And in this case, it's angle A and C. So it's where the short side meets the long side. This full angle is going to be congruent to this angle. If you imagine like angle D, this could be really stretched out and it won't be equal to angle B. So it's the ones where the 1/ meets the 2/. And then the last piece, one pair of opposite angles are bisected. Bisected means cut in half. Well, it's not angle A and C. It's angle B that's cut in half. So I'm going to put 2 marks there and 2 marks there. Those 2 little pieces are congruent. And angle D, 1, 2, 3. 1, 2, 3. So lots of properties when it comes to kite. And if you notice, this right here is a little right triangle. It's congruent to this little right triangle. And this is a bigger right triangle. And this is a right triangle. So we could use Pythagorean theorem, lots of things inside of kites. So let's try it. We just learned that all angles of a 4-sided figure are going to add to 360. I'm given that angle B is 100. So this is a kite, so these are congruent, and then angle B and D would be congruent because it's where it meets the 1 and the 2. So then this is also 100. So then if I think about this, I'm going to have 100, let's call this X, plus 100 plus 85 plus some unknown angle X has to equal 360. So then we've got 285 plus X equals 360. So we're going to subtract 360 from 285 and we're going to get 75. So angle D was 100 degrees and angle A will be 75 degrees. Let's try another problem with some angles. So we're trying to find X and Y. So I have my 2 short sides, my 2 long sides. If this little piece is X, then this is also X. Those are congruent. And I'm going to put 2 marks here for Y. So if that's Y, then that's also Y. If this is 48, then this is 48. If this is 75, then this is 75. Because if you look at it, this little thing here is an isosceles triangle, and so is the other side of that. So I'm trying to find X and Y. Well, we know that the diagonals are drawn and they are all right angles in there. So I'm going to look at this little right triangle. I have a 90 degree, a 75, and an X. So if you do 180 minus 90 minus 75, you're going to find that this is 15. And then the same thing's going to work on this little triangle over here with my 90 degree angle. I have an angle that's 48. Therefore, angle Y is going to be 42. So X is 15 and Y is 42. Let's try the perimeter. So all the way around. I know that MC is 3, MB is 4, and AM is 8, and I'm asked to find the perimeter. Well, those are all information on my diagonal, so we're going to have to work our way out. If this is 4, I know that this is 4 because that's the diagonal that's cut in half. I also know that I have right angles here. So I'm going to use the idea that we just said that we could do Pythagorean theorem. I'm going to say that this is X and this is Y. And if I can figure out those X's and Y's, I'll be able to add them for the perimeter. So I'm going to do the Pythagorean theorem here. So I have 3 squared plus 4 squared equals X squared. That's 9 plus 16 equals X squared. That's 25 equals X squared. So X is going to be either plus or minus 5. We're just going to include the positive side because we're talking about a measurement. So BC is 5 and DC is 5. And now I'm going to do it with the 8 and the 4. So we'll do it over here. 8 squared plus 4 squared equals Y squared. We have 64 plus 16 equals Y squared, which is not what I had. Oh, I did the wrong thing earlier. Okay, so this is 80 equals Y squared. So Y is going to be the square root of 80, and I don't have that written down as a decimal, so I'm just going to say square root of 80. You could hit the decimal and get that. When I want the perimeter, I'm going to add up my 2 5s and my 2 square roots of 80, or the decimal, whichever you have. So I'm going to get 10 plus 2 root 80 for my perimeter. And the area formula. This one's quite different. This uses the diagonals in order to find the area. So D1 is diagonal 1, D2 is diagonal 2. So you take your diagonals, D1, D2, doesn't matter what's short or long, you're multiplying them, and then you're going to either multiply them by 1/2 or divide by 2. So let's try this. I know that MD is 5 and all of AC is 16. Well, I also know that MB is 5. So I'm going to say my area is 1/2 times BD, which is 10, times AC, which is 16, my 2 diagonals. And again, it's all multiplication. I'm going to do 1/2 times 10, which is 5, times 16. So the area on this one is 80 units squared. And we're back to our flow chart. So we did the colored ones. Today we looked at the trapezoid, isosceles trapezoid, and the kite. The trapezoid has exactly 1 pair of parallel sides, and then the kite has 2 consecutive adjacent pairs. Nice job.